We're going to be talking about some recent research and studies that have been done on genomics. As Angie mentioned, two of the participants of that, or conductors of that research, Dr. Vlad Mujica and Dr. Luis Nunez are here with us. I was introduced to Dr. Mujica by Coco Gonzalez. It's been, boy, Vlad, probably at least 3 years ago. I don't remember exactly when it was, but it was a while. And she invited him and someone else who had joined the company to meet together for a breakfast meeting in Phoenix. And I'm pretty sure that while he is a esteemed professor at Arizona State University, he didn't expect to be discussing epigenetics and oxidative stress and gene expression over pancakes at a restaurant or whatever it was that we were eating. And even though that wasn't his particular area of expertise, he certainly understood it readily and had some background. And I think it kind of caught his attention and piqued his interest, which is fortunate for us. And he in turn has started a company with Dr. Nunez and another doctor, Dr. Garcia, who was unable to be here with us today. And that company is called IASOTEK, and we engaged them to conduct some research on genomics. And we're going to talk a little bit about that research, the findings. Some of the findings are similar to what we've talked about before in regards to NRF2 activation and other things, but other things were, some, I wouldn't say necessarily unusual findings, but things that I think we're a little surprised at in a very pleasing fashion. And we'll talk a little bit more about that today also. So good morning, Dr. Mujica, Dr. Nunez, thank you for joining us here today. We're glad to have you. We're going to do this in a question and answer format. And so I think, first of all, let's introduce our group today to you and get a little bit more information. We'll start with you, Vlad. Can you give us a little bit of information about your background from an educational and professional standpoint, and anything else you'd like to add?
Sure. And thank you, David, and the rest of the team and participants for inviting us to this ACTIVZ school. So about my background, I was born in Venezuela, in Caracas, and I went to school at the Central University in Caracas, chemistry. So I'm a chemist. But my inclination from the very beginning was theoretical chemistry. So theoretical chemistry is essentially related to the use of quantum mechanics, quantum physics, spectroscopy, the interaction between matter and radiation, and how to describe this type of things from a theoretical standpoint, so using math and physics. So from the Central University, I did my PhD in Sweden, in Uppsala. And from there, I was a postdoc to Tel Aviv University, and I've been around to several other universities. So I ended up back in Venezuela until things there got a bit problematic that I don't want to abandon that. So then I went to Northwestern University in Chicago, where I met Luis. And after that, since 2009, I have been a professor at the School of Molecular Sciences in Arizona State University. So as I said, my area of research is theoretical chemistry, having to do with electron transfer. Now we are trying to put together a center on molecular sensors, molecular quantum sensors. That is an area that is related to one of the things that I will talk about later. So that's about my background. Now, since David mentioned this breakfast, I cannot help but, I remember it quite well. And what really, he didn't say that, but what really impressed me was not so much that in the middle of a breakfast, we started talking about biochemistry. It was when I asked him, so what is your background? What are you talking about these things? And then he told me that he was a lawyer. I said, wow. Then I was very impressed because David was very coherent and he knew exactly what he was talking about. So I was, you come from the scientific environment and you find this type of interaction, and I found it very, very interesting. So he started telling me about what ACTIVZ was doing. And then eventually I got the attention of Luis and Antonio Garcia, my co-founders and partners in IASOTEK, which is our small entrepreneurship. So that I would say is what I want to add about my background.
Thank you, Dr. Mujica. Dr. Nunez, and by the way, everyone else, there's going to be a test later on. I hope you're taking notes.
Please. Always.
We've got two professors with us today. So
yes.
Go ahead, Luis.
It's always a pleasure. I'm Dr. Luis Nunez, and I started off, even though I was born and raised in the US, I went to undergraduate University of Puerto Rico, and I also did a chemistry degree, and then came back to the US. I got a PhD in physical chemistry, and I worked at Argonne National Lab for almost 20 years. That's where I met Vladimiro, and my specialty has been focused on nanomaterials, biological materials that deal with either drug delivery and species like that. I'm also part of IASOTEK enterprise, which is Vlad and Tony are part of. And I'm an associate professor at Concordia University here in the Chicagoland area. And I'm very excited to talk to you all about the research that we've done.
Well, great. On that note, why don't we, again, from a background perspective, Vlad, we talk a lot about epigenetics here at ACTIVZ. And you'd be surprised at, despite the various backgrounds that people on this call have, they do have a bit of an understanding about epigenetics. But as a scientist, what do you think is really the importance of epigenetics and research in this area?
So I think this is a fundamental question. Before I start answering this question, it's interesting to remember what happened with the COVID pandemic. People were very surprised that in a matter of perhaps 3-4 months, scientists, a combined effort, a joint effort over the world, allowed scientists to actually sequence the virus. And this was a surprise, because sequencing a virus 20 years ago would have taken a couple of years, and probably more. So, but this was solved in 3-4 months. Now, how did that happen? Because there was a very important previous effort. That was the Human Genome Project. And actually we sequenced human genome. So you can imagine a virus is a complicated biological being or a structure, and sequencing it took a combined effort, as I said, but it was done in a very short time. The other surprise is that when people were talking about sequencing the human genome, people were talking about the odds and the path to what is called personalized medicine, because the idea was that, okay, so now that we know exactly how my genome is different from any other person, so then I can have personalized medicine and adapt everything that we take, prescriptions, treatments, whatever, to this genetic pattern that is mine and not anybody else's. But then it came out, even though the word was coined by Conrad Wellington back in 1942, and he was a biologist, British biologist. So the discovery that there were transformations in the human genome that took place due to stress, the way we live, tobacco, alcohol, age, and these transformations were as important as the genetic initial material that we start with. So they discovered that this type of transformation had a huge impact in how we live, and in fact in how we die. changed everything, because all the expectation that was about, sequencing the human genome and we will have personalized medicine, now, in a way, it was put on hold, because we realized that there were things that did not come from the original genetic material, but transformations, this is the epigenetic part, transformations that are induced by stress, by some of the causes, and even random behavior. And this is something that I want to stress because it's related to cancer, and I will probably stop there. But you see, when there's also a very influential article a couple of days ago about cancer and what the origin of cancer is. It turns out that when you ask what is the main event leading to cancer, and then the answer is it's a random event, because it's a mutation. It's triggered by a mutation. Whether that mutation survives or not, that's something else. But now a mutation is a quantum event. It's an intrinsic feature of the molecules that have a certain probability of mutating or not. Whether that so now what it turns out is that a very deep connection between cancer and epigenetics. So back to the initial question. So epigenetics is the study of these transformations in the genome, and particularly in allowing the expression of certain genes and forcing the suppression. It's both effects. It allows new connections, allow the expression, and triggers the suppression. And either the expression or the suppression of certain genetic behavior. This is what we associate with epigenetics. And now we recognize that it plays a fundamental role on everything, life, the behavior. And the last thing I want to say is that one of the things that Waddington discovered was that whatever happens in our genome in terms of the epigenetic transformation has to do with responses that were already there. So what happens is, in a way, determine, influence, but what is already there, because there were many attempts to establish this connection between the way we live and what happens to our genome, and they were never successful. It was only when they understood that it is an underlying mechanism that is associated with pre-existing behavior that we started understanding what the epigenetics is about. And that's an open and fascinating field of research. Again, that's not my own field of research. I'm a theoretical chemist, but I am fascinated by the idea of connecting these two areas of knowledge.
Well, thank you. And that really is fascinating, isn't it? To have a theoretical chemist, someone who focuses on quantum mechanics or the activities of subatomic, very small particles, the smallest particles that we can even imagine, and understanding that pertains to lots of things, including what's going on in our bodies at the genetic level and DNA level. And so that's pretty fascinating, and really, I think, underscores that here at ACTIVZ, we really are involved in cutting edge research. So I think that's a great lead-in, Luis, to so Vlad talked about epigenetics and how science has proven that outside influences, sometimes intentional and unintentional activities, food, diet, stress, all have an effect upon the genome. And so based upon that, can you just explain briefly what the purpose of this study was? What were we looking for?
Well, we were definitely looking for quantitative results of how these activators or outside species molecules can affect basically the protection of the cells, or the reducing oxidative stress. So the purpose that we went forward was to quantitatively prove that certain things are occurring, and that today we have the technology to monitor the activation of NRF2, the activation of certain cytoprotective compounds that are generated. And we were trying to definitely use the scientific base to prove that the consumption of such products are equivalent, sometimes we know this naturally, but are result in improvement of overall wellness and health of the person. So that overall was our goal in pursuing this, and we thought we made significant advancement.
So we wanted to check whether the ingredients in genomics would have this epigenetic influence, if they did anything upon the genes, if it specifically if it caused the expression of NRF2 and other genes. We're going to measure that, like you said, and then the so what answer is, like, if it does activate NRF2 and other things, what are the implications for our health by so doing, right? So can you tell us where was this research conducted?
Well, this research was conducted in various places. The institute in Mexico was one of the locations where we did the experiments. Also in Iowa, yes, Iowa State, I believe.
Yeah.
And we had multiple places, but since we are spread out in different locations, IASOTEK, we were using expertise in multiple locations, from Arizona to Mexico to Iowa State.
So it's kind of interesting. So like you say, from laboratories and scientists in Arizona, at Iowa State University, at the Autonomous University of Merida in Mexico, that's kind of interesting. We had all these scientists working on genomics, the very things that you guys talk about every day. That's was being studied by these scientists. So we'll talk more specifically about this. But again, Luis, before we get back to Vlad, just in a nutshell, what were the results? What did we find out?
Well, we found out that we had we demonstrated that the NRF2 activations significantly increased. We demonstrated that there was also cytoprotection from using this GNX1. And
I'm going to interrupt you there, Luis.
Right.
That's a word that we don't always use. Cytoprotection. What does that mean in layman's terms?
Well, cytoprotection basically are molecules or enzymes that the body could produce to clean up. Typically, they're free radicals that are generated in the body. For example, if you were to eat, in the process of food consumption, besides the acidic process that breaks down into all the great amino acids that we use to produce new enzymes and proteins, this process requires free radicals, because in chemistry, those are the chemicals that can break things apart, for example. At the end of the process, the body has a mechanism to control and to create metabolic balance, meaning that if we don't need any more of these free radicals that could be, kind of destructive, then they get rid of it. And in order to get rid of it, it creates compounds that are cytoprotective, that protect, that pick up these free radicals, pick up molecules and that are going to be destructive and create inflammation. And that's sort of the process of, cytoprotection is simply to do a cleaning of byproducts that could be toxic.
And so that's helpful. And just one more thing, cyto refers to cell, right?
Yes.
And so if you say cytoprotective, it's really cellular protective. It's protecting the cells. And you explained what it's protecting the cells from, and that is free radicals. And when those free radicals get out of, or an oxidant gets out of balance with the antioxidants, that results in oxidative stress. And you mentioned that. Vlad mentioned that briefly. Vlad, what is oxidative stress, and is it bad? Is it good? This audience knows a little bit about oxidative stress. They've heard about it, but can you explain a little bit more about that?
Okay, so I think one way to try to answer that question is first to understand that cellular function, cytofunction now, it depends a lot on using free radicals. I mean, we think of free radicals as something bad. And in fact, they are bad when they are out of control, and they are essential when they are under control. And this is the same, you know, it's interesting to think about this. A human cell is much bigger than a bacteria. Now, we, in a very deep way, we coexist with a huge number of bacteria. How many? Well, some studies indicate that we have in our bodies more bacteria than cells. This is something that is a bit controversial, but then we understand that, you know, bacteria, we coexist with them. We form a bio-integrated unit. And some of our most important metabolic functions, they depend on bacteria. So now back to the oxidation. Oxidation is a reaction that involves, it's a chemical reaction, oxidation and reduction. They involve the transfer of electrons. It's a very peculiar reaction because it doesn't involve changing necessarily the structure. It's not like a water decomposes in hydrogen and oxygen. It implies electron transfer. Now, this electron transfer is absolutely essential for the behavior of proteins in photochemistry, in a large number of, so electron transfer reactions are essential. Now, each time an electron transfer reaction happens, you have an electron going from one place in a molecule to another place in a molecule. And this, of course, when this gets out of balance, this electron by itself is an extremely reactive chemical entity in ways that sometimes we don't understand. So just this one electron being transferred in the wrong direction can cause damage. So when we think about all this extremely complex biochemical landscape, then oxidative stress is what happens when you get these creatures out of control. A free radical. What is a free radical? A free radical is essentially a molecular structure that has one or more what is called unpaired electrons, because most of the time electrons are what they call pair electrons, meaning that electrons, they have a property called spin that has to do with the magnetic moment of electrons without entering into any detail. So in many molecules, these electrons are paired. When they are unpaired, they're extremely reactive. And if they're moving around, remember, so in our bodies, we have a control mechanism. We trigger the cell trigger the electron transfer process. And then if the electron is not used in a very short time meaning 10 to the minus 12 seconds, or even shorter, but the order of 10 to the minus 12 seconds, if it's not used, then it is returned back to the original position, because if it stays there, it can be very damaging. So back to the question, oxidative stress is what happens when you have these creatures, free radicals and other out of control, and that puts a lot of stress in cells and the way cells work.
So like you say, free radicals by themselves aren't bad, but too many are. It's kind of like being out in the sun. The sun is great until you get sunburned and get a little bit too much, right? And oxidative stress has actually been tied to many diseases. This imbalance that leads to that inflammation is kind of like you were talking about, Luis. Some inflammation, the body's inflammatory system, the system of inflammation can be helpful, but too much is not good. And they're all linked, as oxidative stress and inflammation are linked. And we know that one of the mechanisms used to put that oxidative stress level, that's also the primary cause of aging, into a proper balance is NRF2. Now, Luis, you mentioned that we detected NRF2 and could actually measure it. How were we able in this study to detect whether we were causing the gene to express NRF2 or not? What did we do?
Well, it's something that's been developed in the last, I would say, 30, 40 years, that we have the ability now to create a construct that has luciferase, and even though it sounds like
Like the devil.
like the devil name, it's simply because it can create a red color. But in this case, what happens is that the luciferase is tied to the promoter of the NRF2. Now, basically, when I teach biochem, I try to break this down. That what promoters are simply like, if you have a machine that you want work, a carousel, somebody has to turn on the switch, and chemically, that's what promoters do. So, in the case of the NRF2, it tends to link to a promoter that produces antioxidant, basically responsive expressions of genes and enzyme. So we had it tied with this luciferase, which gives it a color. So every time the switch turns on to produce a molecule, the cell glows. So we could quantify, all the cells that actually got activated by NRF2 by using that gene expression. So that's pretty much how we look at the color, and the color glows.
So this enzyme, luciferase, which is actually the enzyme that fireflies use to light up, right?
That's correct.
Is used to, and you basically put it on the cells light up, and you can, and then what? You actually measure, are you able to measure that, the amount of light that's emitted, and what relevance does that have?
Well, we could quantify, because each time light is emitted, it could be counted, and we could count light of certain wavelengths and determine how many cells were lit up, or how many molecules were activated overall. So yes, it's a very, very sophisticated but yet simple way to count.
And so by doing that, we noticed that we tremendously upregulated the amount of NRF2 that was being emitted, that was being expressed. And we know that NRF2 then causes kind of this cascade effect of increasing the production of other antioxidant enzymes, which in turn reduces oxidative stress. And that, of course, by doing that, has that cellular protection aspect that you mentioned. How did we measure, or what did we do to look at this? Because I interrupted you earlier. This cyto or cellular protection. What did we do to the cells to see if the formula really did provide that protection that you mentioned?
Well, we looked at it further down in respect to. So remember that the NRF2 it can generate not just enzymes or proteins, but it could generate genes, and those genes can generate other molecules, and we associated specific genes that were going to be generate molecules that were cytoprotective. And so we did other tests, not just the luciferase, but gene expression, to determine that.
And one of the things that you actually, if I remember correctly, introduced some toxic materials, things that are toxic to cells, to see if it really was cytoprotective, correct?
Right. We increased the, for example, alcohol is toxic to certain cells, and specifically the cells that we use were liver cells, and alcohol is very toxic to liver if you follow some of the diseases that alcohol could generate. And we did monitor to see the effect on these cells, and saw protective nature.
And you noticed that it was cytoprotective or cellular protective against this ethanol, this alcohol that we also introduced into the formula, correct?
That's correct.
So you mentioned some of these other genes that were upregulated. What were those specifically?
Well, the specific genes, I
Well,
mean,
not the names necessarily,
yeah,
Luis, but
yeah, I don't want to put the names because the
they produce.
names may not mean anything to you, but some of them produce products, molecules or enzymes that were very important to protect, not just the liver, but other parts of the brain, like the glutathione is a very cytoprotective. It picks up free radicals, and people have even studied them in cancer and their utility, how to treat cancer. But in this case, free radicals are generated under a lot of diseases that are like inflammation, diabetes, and so forth. So the concept that we can generate that gene through the NRF2 pathway, that was significant.
Recently, many of the people, or some of the people that are on this call, including our next speaker, Karla, we're on a cruise that the company sponsored for those who qualified, and we had another member of our scientific advisory board, Jeff Boast, who works with as a colleague of Dr. Joe Maroon, and they have been, particularly Dr. Maroon is a neurosurgeon, and together the two of them have done over 15,000 surgeries. But they become fascinated with an aspect of what you just talked about, glutathione, and glutathione production being, what the primary fuel in the brain, and low levels being linked to Alzheimer's and Parkinson's disease, other neurological disorders. I think there's always been, I think that's been fairly recent, that type of research, but there's been a large body of research regarding its effect upon being protective of the liver, glutathione, and other things. To you, I'll point this to you first, Vlad. We've given you a break for a bit. What do you think is the significance of the results that we found that genomics actually upregulates these genes that produce more glutathione? Is that, in your mind, is that significant?
Yeah, it is. There's no question about that. It is significant. But before I answer that question in more detail, what I want to stress is that all this effort, because I mean, you guys, you have this company, and of course, company interest, they either overlap or they don't, with the knowledge, increasing knowledge, the importance of knowledge for society. They might. And the reason why I am happy in having this collaboration, this, I don't know exactly, this partnership, whatever we want to call it, with ACTIVZ, is that I see an interest in carrying, as far as possible, rigorous scientific research that supports what you guys do. Now, to me, that's extremely important, because I mean, there are many products out there, and they try to sell you these products, and there is no scientific study about the relevance or the availability. I mean, this is an important question too. I mean, sometimes you take some of these products, and then the question of what is called bioavailability is not answered. So they don't know whether these products actually get to their targets. And this is a problem that has been in medicine for a long time. I mean, wherever we try to get to the brain has protective barriers. Not to alcohol, that's why we get so much influence by alcohol, but to many other chemicals that are barriers. So then, back to this question. What we tried to do here was to increase knowledge on this and study in a very rigorous way from a scientific perspective what the active product in this Genavax could have. So now I think that this aspect of being able to connect this to brain diseases like Parkinson's disease and Alzheimer, this is a fascinating, this is a frontier field. This is not just a field for the company as such. We don't know how the brain works. We know a few things, very important things about the biochemistry of brain processes. But in detail, what exactly leads to this type of, that other type of brain disease, we don't know that. So whatever can give us some knowledge in that direction. Now back to your question after all this lengthy introduction. Yes, I think it's a fundamental importance, David.
Well, thank you. Luis, have we basically covered, so we talked about the fact that the research showed a big uptick in the expression of NRF2 in the results. We showed a cyto or cellular protection aspect to the formula and reducing oxidative stress. We showed this upregulation of genes that produce glutathione, and we know that that is relevant to our brain and to our entire systems as a very potent antioxidant, particularly in the brain. And that was primarily the areas that we researched. Am I forgetting anything in terms of the results and things that you've covered?
No, I think that covers pretty much everything that we pointed, and these are significant advancements of understanding of this system of a natural product. I mean, because not most natural products, may or may not have huge activity, and this particular product does.
Well, on that note, Dr. Nunez and Dr. Mujica, I think everyone would be interested in your answer to this question. Would you recommend then that based upon the results of the study and things that you know about the importance of some of these results, that people take genomics?
I say absolutely.
Absolutely. Again, yes, I would, but it's in the same way that you take any important decision in your life. You have to be aware of what is happening after you take this decision. And see, I mean, the younger you are or the older you are, what is happening to your body. Sometimes it's very difficult to follow exactly what is happening. But I would certainly recommend. I don't think David will like that I use the expression, I will take the risk. And
I don't mind that at all. In fact, one of the things that we tell people here at ACTIVZ is to really pay attention. The reason that we chose the name ACTIVZ for the company was that we believe that there are many things in regards to our health, in regards to our financial well-being, and in regards to all aspects of our life, that we really can control, that we don't just have to sit back and be a passive participant in life, and that we really should pay attention to the things that we put into our bodies and the things that we do and see what the results are. And yes, we do want to certainly supplement that attention that we're giving our own bodies with outside research and something that corroborates what we have been saying about the claims of about the benefits of the product. And obviously, to everyone on this call today, to listen to distinguished and knowledgeable scientists talk about the research and the interest that it is to you, and your recommendation is very important. But you're right, that doesn't excuse every single person from taking the responsibility for finding out and paying attention to what they do. Now, I will say this, and I put them on the spot. Aren't you guys actually glad that I asked them the question? Do you recommend that everybody take genomics? Because we recommend everybody take genomics.
I like this question. So, David, you're a combination of a lawyer and a biochemist, and also, you are good at doing this type of stuff. Yeah, I think it's an important question, because in the end, if we say all this and then we say, well, I have never taken this and I wouldn't recommend it to my grandfather or whatever, my mother, then it doesn't look good. But then we have to say that in a way that people believe us, because if we're saying that out of a corporate interest or because we want to have a good relation with you guys, then we are not credible at all. So it is important that we say from our own perspective. And if we find out that there is something that is missing, whatever, in our research, we will certainly tell you within the boundaries of this confidentiality that it surrounds all this. Yes, but we will tell you. And we want people to understand this. And I finished, I know that this was the educational value of all this discussion. Because you see, society take for granted science, medicine, technology, they shouldn't take it for granted because there is a lot of research behind all that. And it is very expensive research that sometimes, in very limited number of cases, leads to advances. In many occasions, it leads to frustration because then you discover that you were doing not going to work. So people need to be aware of that, I think. So the educational value of this type of events, for me, is very important.
I agree. And on that note, I'll just thank you both for participating with us today. And for everyone else, you can expect to hear and see more from Dr. Nunez, Dr. Mujica, and their colleague, Dr. Garcia, because we're going to be putting together some materials, some videos regarding this research. And we are currently in discussions about additional research, this time not simply on human cells, but actual humans themselves. And having a study that now shows that we've been able to go from the cellular level, kind of the laboratory level, to in vivo, in the body, and prove the bioavailability and take it from a theoretical standpoint to an actual proven standpoint that we really are reducing oxidative stress in bodies, in all of you. And you know, I think that it's great to listen to me, to listen to them and say, oh, they sound like they know what they're doing. But there's nothing that is a substitute for really saying, wow, the science proves it. It's not just their opinion. It's just not, Dave is not just saying this because he's a CEO, and they're not just saying this because they're doctors paid by the company. This is real research that has been proven to have this effect. And that's something that we're striving for. And we're not, you know, we say that ACTIVZ is a different kind of company, and I like that. We are different, and we celebrate our differences. Often people say, David, you're way too much steak and not enough sizzle, and that's all right. We concentrate on things that are real. What you see is what you get, and we know that it's not easy being a distributor and going outside and sharing these things with others because there's a natural skepticism that people have, and so we will always strive to give you cover in the cover and support in the forms of scientists and scientific research and others who are saying, yes, this is real. You should take this seriously. So Dr. Nunez, Dr. Mujica, thank you very much for joining us today. You're welcome to stay on, or I'm sure you have other things as well on this beautiful Saturday to take care of, but we look forward to seeing you again down the road. Thank you again.
Thank you for the invitation. Unfortunately, I have to take off, but it was a fantastic experience. Yeah.
Thank you. Okay, Angie, back to you.
All right, and actually, Ian's going to introduce our next presenter. So I'm going to turn the time over to Ian to introduce who we have next.
Thank you so much. And I'm going to second what Jerry said in the chat. David, steak is my favorite meal, so I'm okay with that. I have the great opportunity today to introduce one of my favorite people that I've met since being here at ACTIVZ. Karla is a mother of 2 children who are just the most amazing kids. We had a lot of fun with them, and we've seen them through some of the trips that we've done. Karla studied computer systems engineering and did a master's and PhD in France. She worked for, as many of you guys know, one of the most wealthy people in the world, Carlos Slim, for a long time, and decided to leave that job to become a mother. Then, as she was working and becoming a mom, having her kids, she found network marketing as a way to grow professionally, but still focus on being a mom. And so something that she's done is be able to grow her business, not only by herself, but also with her own mother. And it's been so cool to see them both qualifying for trips, going on some of the Momentum Escapes that you guys have seen. We shared a lot of time with Karla on the cruise. And actually something that I wanted to highlight that I saw specifically on the cruise, a lot of people were having fun, taking in the sun. It was a big vacation for a lot of people. And I think maybe 1 or 2 days into the trip, Karla came to myself and Angie asking, hey, can we set up an opportunity meeting on the boat so I can do some prospecting? And I think that's just such a good example of who Karla is and how hard she works. One of my favorite quotes is, if you do today what others won't, you can accomplish tomorrow what others can't. And I think Karla encapsulates that perfectly. And she does such a good job at everything here. also, just on top of all the work that she puts in, something that's really cool about Karla is that if you walk into a room and you see the people that look for the happiest person in the room, it's gonna be Karla. That's gonna be her every single time. So without further ado, I'd love to give the time over to Karla. I'm gonna put you as a spotlight here and let you take it away, Karla.
Wow, what an introduction. Thank you very much. I'm gonna share with you my screen. Okay, wow, well, thank you very much, Ian. Thank you for that introduction. Oh, now I am more nervous now. So, well, hello everyone. Thank you for having me. I'm having, wait. Thank you very much. Well, again, my name is Karla Lopez. I am from Mexico, Mexico City. And today I'm going to share with you information that helped me to take my network marketing business very seriously. So I will explain the most important characteristics of different types of businesses. So, first of all, why do you want a business? If we are taking time to analyze different types of businesses, it's because you are interested in a business, right? So why is it you really have to think about it? Remember, your why is very, very, very important. It is because you want extra income, because you want to make a dream come true, because a single salary is not enough, because you want to have a plan B. No business is easy. So you have to stick with it with a strong why. So the very first thing, the very first business I am going to talk about is traditional business. So number one, you must pay a high initial investment, right? For example, if you want a business of clothes, for example, you must invest in a store, in the clothes that you will sell, counters, etc., etc., etc. I don't know in USA, but in Mexico, it is at least $5,000. Start very basic, very basic. Number two, save it for 3 years so you can grow your business and make it strong. Why? Because the 86% of the new businesses go bankrupt because they are not strong enough. So you must reinvest your income in the first 3 years. Number three, warehouse, store, whatever you need to save or display your items. In the clothing example, display clothing. Number four, shipping. You must look for a company that helps you with the shipping of your product. 5, marketing. You must invest in marketing so you can sell, right? 6, tax authority. You must register yourself with the treasury, right? 7, lawyer. You must look for help of a lawyer to sign agreements with your suppliers, for example, with your employees, etc., etc. 8, training. You must invest in training, social media, taxes, accountancy, etc., etc. 9, try and failure. In the clothing example, you will have to learn what type of clothing do your customers like the most and what type of clothing do they not. And the clothes that remain, you must put them on discount, right? So you don't lose so much. Then, retirement. How and when are you going to retire yourself from your business? You have to think about it. 11, scalable. Is it viable for you to scale your business? Can you have your business in Dallas and at the same time in New York? 12, employees. One of the most difficult things in a traditional business is the relationship with employees. They don't take care of your business with you. For them, it's just a job, yeah, right? If they sell or not, they don't care. 13, you are the main actor. You must take care of everything. Another type of business is franchises. So, characteristic number 1, very high initial investment. Worldwide franchises are worth a lot of money. One of the number 1 franchises is McDonald's, right? And it is worth more than $1 million. Do you have it? Number 2, savings for 3 years. So again, you must have savings because you need to think about paying enough the $1 million loan, right? As quickly as possible so that you start making profit. 3, warehouse, store, whatever you need. 4, shipping. Again, you must look for a company that helps you with the shipping of your product if you need to. 5, tax authorities. Again, you must register yourself with the treasury, right? 6, lawyer. You must look for help of a lawyer to sign the agreement of the franchise. It is very important because there is a lot of money at stake and you should know what you are signing. 7, training. To run a franchise, you have to train a lot, day and night. It is a requirement when you buy a franchise. Sometimes it is free and sometimes it is not. 8, retirement. Again, how and when are you going to retire yourself from your business? 9, scalable. Is it viable for you to scale your business? Can you have your business in Mexico and in USA at the same time? Maybe yes, but at what price? And at the cost of what? 10, employees. Again, you have to think about how to reward your employees so that they work as they should. Just saying it has already worn me out. 11, you are the main actor. You must take care of everything. Another kind of business is investment. So number 1, to really live off your investments, you have to invest a lot of money. 2, again, you must have savings for the first 3 years so you can pay your rent, your food, your gas, everything, and reinvest your money. 3, greater profit, greater risk. 4, less profit, less risk, but you won't be living up your investment. 5, training. This is a very serious thing here. Here, you do have to invest a lot of time, money, and neurons in training. It is not just any training. 6, trial and failure. When you win well. But when you lose well. You need nerves of steel. Do you have them? Retirement, of course. Can it give you money while you sleep? Of course. And number 4, now, what is the best business option? Of course, omnichannel network marketing. Why? Because number 1, Minimum initial investment, $500. Come on, it's ridiculous compared to everything we just saw, right? 2, zero risk. You will receive products for every dollar, even more products than you are paying for. In the worst case, you will consume and feel better. You will even gain health, right? 3, weekly and monthly income that you can quadruple for the same effort. 4, benefit from leverage. I will explain this point later, but it is the best way to earn money. 5, time flexibility, even at the beginning. On the other hand, if you work more, you earn more. There is no limit. It is the fairest way to make money. 6, there is no warehouse. The company takes care of that. 7, you are not in charge of shipping. The company takes care of that too. 8, there are no advertising costs. Social media is free. Did you know that? 9, diversify your income because you can combine a job with this business, for example, with zero risk. 10, no extra paperwork. You don't need a lawyer. We have already the best lawyer in the world and also a scientist almost. David Brown is our CEO. 11, free training. We have these wonderful trainings every month, and during the week, we have free training by great leaders. 12, proven system. If you follow the success guide to the letter, you will be successful. No doubt about it. 13, you work from home or from whatever you want, even from a boat. 14, retirement, of course, faster than anywhere else and with the limit that you set. 15, partners. We don't have employees. We have a team, people with the same vision as ours. You don't have to fire anyone. 16, unlimited income, residual income. You don't have that in a traditional business. You don't have that in a franchise. 17, scalable, of course. We have international expansion with global funds per country. 18, you receive a percentage of sales from different distribution channels. So, why is it the best way to earn money? Because we are benefited from leverage. What is it? I'm going to give you an example. If you can dedicate 4 hours to this business, which do not have to be consecutive, it can be 1 hour in the morning, 1 hour at noon, and 2 at night. And you find 4 people who can also dedicate 4 hours to this business, you will earn money which comes from 20 hours of work. 4 hours times 5 people equals 20 hours of work a day, with only you having dedicated 4 hours to it. That's why we can earn in a year what an employee can earn in 10 years. So this is the power of leverage. Another example, linear income comes from 100% of your effort. How? Let's make some math. You open your store 50 hours a week. Let's say working 8 hours from Tuesday to Sunday in a mall, for example. Times 50 weeks a year equals 2,500 hours a year. Times 40 years equals 100,000 hours. So when you work in active, you make residual income because you have a network. Let's say 100 people working 10 hours a week or part-time equals 1,000 hours a week times 100 weeks, so 2 years, equals 100,000 hours. So we work in 2 years what a traditional business owner works in 40 years. So what do you prefer? Your 100% or 1% of 100 people? To finish, I just want to point out again the main characteristics that we should look at when choosing a network marketing, and realize that ACTIVZ has the 5 characteristics, and it is today the best option. We have consumable products, not any product. A company led by the best. We have only 6 years in the market, 5 years in USA. We have a proven system, and we have the best compensation plan. And cherry on top, we are the company that has grown the most in the last 4 years, year after year. And that's only because they don't have records for the last 6 years, right? So we are in the best company. Thank you so much. I hope this information is useful to you as much as it was to me.
I hope you guys were taking notes throughout the whole active school. This was incredible information from Dr. Mujica, Dr. Nunez, Karla. Thank you all for your participation today. I know that I learned a lot. And sometimes when I hear these distributor presentations, it makes me wonder, like, why am I on the corporate side? But I also know that distributors need corporate people like us to make sure the shipping happens and make sure that everything is taking place so that you guys can focus on building your residual income and building your business. And I love working with people, especially people like Karla and all of our wonderful distributors. I think David says this often, but our most valuable asset that the company has is our distributor leaders. My child's telling me to stop talking. And he's absolutely correct. Give me just 1 minute, okay, buddy. Without our amazing distributors, we would not have this incredible company. And without the amazing doctors that we have and scientific advisory members, we would not have this incredible company. And I will say, like, I've worked for a lot of companies, and ACTIVZ has been my most favorite company I have ever worked for. And it is because of the people that we work with, from the corporate staff to the distributors to the doctors. It is an incredible team, and it's amazing what we have been able to accomplish in the last 6-7 years. And Karla's absolutely right. I don't know of any other company that has grown over the last 6 years like we have. And when you reach out to, I've talked to many different vendors, and there's a lot of network marketing companies that are not succeeding and they're not growing. But because of the incredible leaders that we have and the passion that they have for the business, we have been able to maintain and to continue to grow over the last 6 years, which is absolutely incredible, especially given what our world has gone through, especially during COVID. So thank you to all of our amazing leaders. Thank you, Karla, for presenting today. Thank you, Dr. Nunez. Thank you, Dr. Mujica. I'm going to turn some time over to David so that he can finish the call up.
Well, thanks. And thanks, Hunter, for letting Mom talk a little bit. That's great. We're glad that Karla was able to give such a great presentation. Definitely not surprised at that. You know, it's interesting. We started off with scientists who were talking about the science of genomics and oxidative stress and all that type of thing. And then you got introduced to, I'll call her Dr. Karla Lopez, because in many ways, in her world, she's a doctor and a researcher. Her research laboratory is the real world. And when she tells you that following the success guide is what it's going to take, that's exactly like the scientists following the steps of how you do a particular assay or how you conduct the research. They don't just go off and make up stuff on their own. They follow a pre-designed set of steps in order to test and measure and quantify the results. And when you do that, if anybody knew what those steps were, they could do it. And that's what Karla's done. She's proven in the laboratory of ACTIVZ that it really works. And so we're grateful for her participation today. I'll address a couple of things that were in the chat. I think Coco's one of our resident scientists as well, and she had a couple of questions. They did not measure specifically glutathione levels. They measured the fact that the genes that produce glutathione were upregulated by a certain percentages, which we'll talk about later. So we know that the upregulation of the expression increased, and the measurement of catalase specifically, which is an antioxidant enzyme and is also very much involved in reducing oxidative stress, is certainly produced by virtue of NRF2 production, but that was not a particular focus of the study itself either. So those two things weren't measured. You asked a question about the regulation of mitochondria. Of course, one thing that NRF2 does is that very thing. It regulates when NRF2 levels are low, mitochondria damage increases, as well as by the way, sometimes I don't want to get off too much into a scientific discussion again, but those free radicals that the scientists were talking about, they damage the cells and they damage the mitochondria. And what happens when they damage them, they produce byproducts. They kind of cause breakage. And so that breakage kind of creates a bit of a junkyard in our cells. Those pieces of former cells and cells that have died and things like that can remain in our cells and cause problems. And so NRF2 actually helps clean up those cells as well as the rest of the trifecta. It's interesting to note that the other products, particularly Link and Optimend, operate on some of the same pathways that Genomics does, but in addition to Genomics, it operates under other pathways in order to also cause gene expression to the extent that it strengthens the immune system, reduces inflammation, and goes about in that way. Coco's mention of catalase kind of reminds me of something that Dr. McCord has talked about in the past. Catalase is one of these antioxidant enzymes. And whenever anybody says, well, why do I need this? I get my antioxidants from food. I eat berries. I drink red wine. A lot of people think, man, if I just drink more red wine, I'll be healthy. I'll be really healthy. And that's why people like to really drink a lot of red wine. But as Dr. McCord will tell you, is that when we produce free radicals, and they explain to you chemically what free radicals are, but we produce something along the lines, if I remember correctly, 19 followed by 21 zeros worth of free radicals every day. If we exercise, we produce more. If we're sick, we produce more. If we're in a polluted environment, we produce more. If we're eating lots of food, we produce more. And so that's a lot of free radicals. And when you take your antioxidants from food, they will actually, they can fight or take out, destroy the free radical, but only on a one-to-one basis. And if this is your word for today, mark it down. Dr. McCord taught it to me. The scientific term for one-to-one is stoichiometric, okay? And maybe in a future meeting, Angie and Ian, if somebody can remember stoichiometric, we'll give them some reward points. But you simply cannot eat enough berries. You cannot drink enough grape juice. You cannot drink enough red wine to take out on a one-to-one basis all the free radicals. Because when antioxidants that come from food interact with a free radical, yeah, they take it out, but they're destroyed in the process also. But Coco mentioned this antioxidant enzyme called catalase. Did you know that catalase, as opposed to an antioxidant from a berry, catalase, one molecule of catalase can take out 1 million free radicals every second without being consumed in the process. So as Dr. I think it was Dr. Mujica who said this, that, and I love saying this, is that what genomics does in our products is not change what the body does. It just allows the body to do what it's already designed to do. We simply put it back in position to release that catalase, which is the body's most effective way of fighting these free radicals. And so putting that oxidative stress in proper balance, modulating the immune system, and putting things on an even keel and putting things in balance, that really is what we're doing with genomics and actually all of the ACTIVZ products. And so we're trying to bring balance scientifically and from a health standpoint. By the business opportunity, we're trying to bring a little bit more balance. Actually, it's okay. I think all of you would say it would be okay to be out of balance financially if you had a lot more money than you needed every month for your bills. That type of being out of balance is fine. Being out of balance the other way, when you have a lot more bills than you have money every month, that's not a good balance. That's kind of like oxidative financial stress. So we're going to reduce both of those type of stresses, and by utilizing our products. And one of those products really is the opportunity. So we're glad that Karla is a scientist in the ACTIVZ lab and demonstrated what it takes for us to succeed. And I want to just urge you all, if there's something new that you learned today, share it with somebody else and tell them why you thought it was interesting and what it meant to you. And I think that that's a good place to start. It doesn't have to be perfect. You don't have to talk about the chemical pathways that Dr. Mujica was talking about, but it is interesting to think that we have these scientists who didn't know anything about this area of science, and once they started looking into it, they were fascinated and saw what the ramifications on our health truly are. And now they're eager to do more and more research on behalf of ACTIVZ. So I think that's pretty exciting to be part of. More importantly, as Angie said, I think it's pretty exciting to be part of this group and with all of you. So thanks for being with us here on a Saturday. We hope you enjoy the rest of your day. And Ian, I think you're going to do a little giveaway for us, right?
Angie's gonna help me out with that.
Oh, okay.
Yeah. We are going to we're going to give away 100 reward points, and I'm not sure why it's not letting me share my sound. This might be another boring wheel of names because we don't have any sound playing. But we are going to give 100 reward points to 3 people plus Karla. And then Karla, if you happen to win, you're going to have to gift your reward points to someone else because you're already going to receive the one. Some for being our presenter. So here we go. We're going to share our screen, and our first winner is Wayna, congratulations. And it was so good to have you on the cruise with us. But congratulations on your 100 reward points. Send your ID number in the chat and we will get those added. Winner number 2. Catherine, congratulations, Catherine. Also, if you will put your ID number in the chat, we will get you your 100 reward points. And winner number 3. Norma, congratulations, Norma. We'll get you your 100 reward points. Get your ID numbers in the chat so that we can get those reward points added to your accounts. Again, thank you all for joining us on a Saturday. We really appreciate everyone jumping on. This was such an amazing ACTIVZ Schools. It was great to hear from Dr. Mujica and Dr. Nunez, and also from our legacy A12, Karla Lopez. So thank you all for joining. Just a reminder once again that our Founders Call is Monday at 6 p.m. There is a YouTube link that was sent out on Telegram. So that is how you'll be watching the Founders Call. And then again, we have our corporate update call on Wednesday at 1 p.m. So be sure to join us for those calls. And thank you once again for joining. We hope you guys have a great Saturday. We'll see you soon.
Thanks, everybody. Have a great weekend.
Thanks, everyone. Oh, and there's a question. We will get this presentation uploaded to YouTube so that you guys can watch both the doctors and Karla, and then we'll separate them out. I'll get the recording uploaded today, and then we'll separate them out so you just have the doctors and just have Karla. But be sure to join or share the recording with your team. But thank you all for joining, and we will see you guys later.
Thank you. Have a good weekend.
Thanks, everyone. Have a great weekend.
Always, thank you. Thank you.
Thank you.
Thank you. Thank you.
Bye, everyone.